Okay, so this is a very long and important problem. And this is actually a one-dimensional um, motion problem. So when an object is thrown up, it will slow down because gravity is pulling it down, correct? And eventually it'll stop at the top. And that where it stops, VO is equal to 0. We call that H max. That's the maximum height. And that will happen at T max. And those two quantities are very important. And so that's what we're being asked here. The maximum height it can reach, so that's H max, and the time taken to reach that height, T max. Okay? And then the third one is the instantaneous velocity at the end of 60 seconds. And then finally, when will it height be 10 kilometers? Okay? Now, because the velocity is given in meters per second, you should solve this problem in meters per second, but report the height in kilometers. Okay? And this is actually a very important problem to show you why airplanes, when they're in the war zone, they have to have a certain altitude so that they're sure that the artillery cannot hit them. Same thing for spy planes. Okay? So what's the first one? H max. And the since we are not given the time, right? What we're looking for is the height. We're going to use this. V squared is equal to VF squared is equal to VO squared plus 2AD. Okay? So we write that here. A is equal to VO squared plus 2AD. Okay, and what we're looking for is the D. Now, the final velocity is 0, right? At the top, we write here VF is equal to 0. Okay, so if we move that to the other side, it becomes 2AD is equal to negative VO. Okay, this is positive, but if you move it to the other side, it becomes negative. So to get the D, we divide by 2A. Okay, and I'm doing this very slowly so you'll see how it's done. Okay, so that D is now H max. Correct? The D is the distance. Okay, is equal to negative squared. And remember that the negative sign is outside. Times 2, and then here, very important, when the object is going up, it is slowing down because gravity is opposite of velocity. The direction is this way, the acceleration is going down, so it's getting slower. That means it's negative 9.8. Okay? Okay. And, oh, sorry. I guess we're substituting already. This is 500 meters per second, but you have to square that. And the answer I got was 12,755 meters, or equal to 13 kilometers. Okay, so please check my math. Okay, letter B. Letter B is the maximum height. Okay, now we're using this formula. VF is equal to VO plus AT. That's the definition of acceleration. So again, write that down. A times T. And what we're solving for is T. this again becomes 0, and so transposing, t is equal to negative, again when you move that to the other side it becomes negative, divided by g, right? Which t max, that's the time it takes to get to the height, is equal to negative 500 meters per second divided by negative 9.8 meters per second squared. And again, the reason it's negative is because it's going slower. Okay, and so the answer to that is 51 seconds. Okay, so it'll take T max is 51 seconds. Okay, so I hope we can still see that. Okay, now I have to move. Okay, all the way down. All right, so letter C. In letter C, we're looking for the final velocity at t is equal to 60, which is pretty straightforward, so we're just going to use this equation. So the final velocity is the initial velocity plus a times t, okay, which is 500 meters per second plus g is still negative 9.8 meters per second squared times 60 seconds. And the final velocity that I got was negative 88 meters per second. Okay, and what does that negative sign mean? This is now going down. Okay, it's changed direction. So look at it this way. At 51 meters, it reaches the top. So after that, it's to start coming down. So 60 is definitely after 51. So it's on its way down. Okay? All right. Letter D. Letter D is harder. When you're looking for time, you can use this equation, which is the height, which is equal to d. Use the general equation, do plus vo times t plus 1/2 g t squared. Okay, this is 0, and you will have a quadratic equation. So your h is equal to 500t plus 9.8 divided by 2 times t squared. And that's a quadratic equation. You can use quadratic formula. An easier way to solve it would be this way. If you're not familiar, if you don't like quadratic equations, you can solve for the final velocity. Final velocity squared is equal to VO squared plus 2A AD. Okay, and so it'll be the square root of, because we want to cancel that, 500 squared plus 2 times negative 9.8, right? Times 10,000, because 10 kilometers is 10,000 kilometers, right? And so your VF here is 230 meters per second. Okay, now that's not what we're looking for. What we're looking for is the time, so we have to use this. So t is the final velocity minus the initial velocity divided by g. Okay, so Final velocity is 232 meters per second minus 500 meters per second divided by negative 9.8 meters per second squared. And the answer would be 27 seconds. Because 27 is less than 51, it's still going up. Okay? Check. Hope that helps everybody.